right, today we're working with this big idea. Gravity is a force that pulls objects down. Stormy, is this true?
Yes.
How do you know?
Because we're not floating.
We're not floating, right? Yeah. Is there any other way that we could test to see if this is true? Austin. Very good. So use an example of a trampoline. When you jump on a trampoline, you fly up, but you always come back down. Okay, what's another way we can test to see if gravity is a force that pulls objects down?
So if we had a tennis ball, we could just throw the tennis ball in the air, or just drop it, and then it'll just fall down.
Very good. If we had a tennis ball, we could observe it as it bounced up and fell down. What's another way we can observe to see if gravity is a force that pulls objects down?
We can jump up while
Oh, okay, so we could jump. So you're saying, whoa, you introduced something neat. Does gravity affect everything equally? Oh my gosh, that's a great thought. Does gravity affect everything equally? Huh? Carson. Very good. Excellent. So we can observe a pencil like we could a ball. But if gravity is a force that pulls objects down, let's come back to this excellent question by Michael. Michael asked, does gravity affect everything equally? Horn. Okay, so you're saying things fall at different speeds? How come? Oh, okay. So there's got to be some examples. I'm confused. You're saying things will fall faster than others. Alright, so you're saying that if I threw a baseball up in the air, or a tennis ball, or some sort of ball, right? If I threw a baseball up in the air, and I just dropped the other one, then this one's going to fall faster, or this one? Okay. Does it matter that I'm throwing them in opposite directions, basically? Because obviously this one's got going in this direction, so it's gonna take. Is it gonna take longer to fall? Okay. So you're saying that there are factors that affect the speed at which things fall. Alright? I need your help then. I need a list of them. What affects the speed at which something falls? Affect speed of falling. You said what? How does weight? so you're saying the things that are heavier are going to fall faster than things that are lighter. That's an interesting idea. That means you could change if you wanted to. You know, like you do things in a video game, you can change. We could change some things and get things to fall faster and slower. All right, so heavier is quicker. Anything else that we can think of that affects the speed at which something falls? Levi. It's mass. And we remember that our mass and weight the same thing? No, very good. Which was weight was what and mass was what, I forget. We went over that many moons ago, did we not, Kyle?
Mass is how much space an object takes up.
So you're saying bigger things. How do bigger things with a bigger mass, how does that affect the speed or the rate at which they fall? The bigger you are, the what you fall. What do you think, Kyle?
The harder to fall.
All right, so you're saying it's going to be slower, bigger things should be slower as they fall? What do you think, Carson? The height at which you drop it?
So if you have like two tennis balls, if you have one that's down here and one up here, this one is going to hit the ground first, but the one that's going to fall faster is the one that has a long time.
All right. Is it one actually going to fall faster, or is it just the distance that's affecting it?
It's the distance.
All right. So distance can affect. Anything else? Levi?
How much velocity it picks up?
What does that mean?
Means like it picks up speed.
So does everything pick up speed?
It depends on how high you drop.
All right. So that's kind of distance, right? Kind of distance. Carson?
I think that the bigger the object is, the faster it is.
The faster. Oh, so you're saying you think of the opposite, Kyle. You're thinking that, is it heavy you're thinking of, or is it bigger that you're thinking of?
I think
All right, so you're saying that bigger objects will fall faster. Do bigger objects will fall faster? Today, I thought it would be interesting to build the helicopter patterns that we talked a little bit about. Online, right? To test a few of your ideas that you have about what affects the falling speed, the speed of falling objects. But I also want you to be thinking about other ways that you can test ideas about gravity. And a question I really want us to think about, other than does gravity affect everything equally? Is there a force that opposes gravity? Is there anything that can defeat gravity? Think about it. You might have an idea in your head already. I can see Kyle motor truck. But something to think in mind. All right, so in your buckets at your seat, I have the pattern. I gave everybody a pair of scissors, and there's also a paper clip in there. You need all three of these things at your seat. So get them out of the buckets for me. And I'll walk you through what to do, even though you could do it yourself by following the instructions on the side down here. This is the first time we've seen these, right? So the first step, step one, says cut out the pattern. You're going to cut on every solid line. So I'm going to show you. I'm going to cut out the pattern first. It's going to look like a great big old rectangle. rectangle like I asked. No. Did I cut there? Where did I cut? I want to see you try, because you're running out of time for people doing stuff for you, and so you've got to start branching out on your own to see what you can do independently. Where do I want you to cut? Look at mine. Did I cut all the way around the outside? You need to cut all the way around the outside. Start here. You need a different pair of scissors, kids. Try these. Good job, Bryson. If it's a solid line, I would say yes. I know, right? All right, if you're with me and you cut out your big rectangle, now you're going to cut where the little scissors are, up to the dotted line there, and up to the dotted line on either side. So it makes almost, it looks like a capital letter T. Do you see that? So anywhere there's a solid line and a little pair of scissors. Do me a favor, you can ball up your trash and throw it in the bin. Did you cut out your big rectangle? Oh, good. You're fine. Yeah, you still need to cut around here. Cut that around here first. Keep trying. You're almost done. Are they dotted or are they solid? You only cut on the solid lines. Leave the dotted lines alone. All right, now we're going to fold. So you need to put your scissors down, pick it up. You should have on one side these two that look like little legs. Look at them running little legs. They're so sweet. And then you should have this capital letter T on the other side. We're going to start on the capital letter T side. Alright, so on the capital letter T side, do you see the dark gray? You're going to fold it over so it's facing you and fold on the dotted line. And on the other side, that gray gets folded over. So look, it looks even more like a capital letter T, doesn't it? With legs. You ready? Oh, good job, Bryce. Good job. Good job. Wait. You're doing it perfect. Alright. Scraps and scissors need to go in the bin. Except for if you have to cut on your dark black lines. I need to cut this line to right here and this line to right here. These dark lines. Otherwise, you're good, kid.
It's like a brush with oversized bristles.
I know, right? Alright, so looking at it again, do you see this long dotted line on the other side? Hey, let's look at me. See that one? You're going to fold one away from you on the dotted line. And you're going to fold one towards you on the dotted line. So look, watch. Put your hand down and learn something new. It should look like this when you look at it sideways. Right, Rachel? Fold one towards you. Fold one away from you. Don't cut that, Tyler. You only cut on solid lines. So you were done. This is it. Look. Yeah, Fold one away from you. Fold one towards you at the top. All right, last step. You got everything perfect.
No, it's bending. Going sideways.
All right, fold one away from you. Fold one towards you. This last step is the easy part. Although some people haven't used paper clips before, and that kind of surprised me a bit. Paper clip skills are important to know. Alright, so you take your paper clip. You see it's got two U's, right? It's got two U's, two rounded ends. You need to put one on one side of the paper and one on the other side of the paper.
Here?
Right there at the bottom. Good job, Kiana.
I'm not so
Perfect.
Wow.
All right. What are we testing with these things? No, the helicopter is what it is. What are we testing with these things? Stormy.
Gravity, and we're saying that gravity affects everything equally, and is there a force that opposes gravity?
Very good. So we're testing. So I want you to stand up. And I want you to test it. Take it away. Maybe it won't catch on something. Stand up and test it. Anybody needs paperclip help, raise your hand.
Wait, I Let's make it rain helicopter.
Hold it up.
Do we get to keep it?
Alright. Is gravity affecting all of your helicopters? Alright, so it's affecting all of our helicopters. Are they all falling at the same rate?
No.
Are you sure? If I release one of my neighbors and mine at the same time, shouldn't they hit the ground at the same time?
Yes.
They do! Okay, so they're falling at the same speed. They're falling at the same speed. Is there anything we can change on these helicopters? What could we change on these helicopters? Just affect their rate of falling. What could we change to make them fall faster or slower? What's some ideas that we have we could try? Stormy.
You could make the wings a lot bigger.
We could extend the wings out a little bit. All right, I want you to try it. I'm going to give you a bit of tape.
Here we go.
I want you to try it. If you don't want to try it on yours, you can tape it to mine. All right, so we're extending the wings. Let's see, what's another way we can affect the speed or the rate at which these things are falling? Horn.
Add another paper clip.
I could add another paper clip. A smaller paper clip or a bigger paper clip?
Bigger.
All right, so who would like to try it with a bigger paper clip?
Me.
Big.
Well, I just need you to raise your hand and I can see you just fine. Now maybe I'll let you take that home. You gonna try it with a bigger paper clip? Okay. Oh, sure. Give me a piece back. Okay, that's neat.
One way that another thing they'll take this and they'll fold it like this so it's sticking down.
You want to try that? Try that.
Can I try that one?
Yeah, go right ahead. So you're saying maybe folding the wings in a different pattern will affect the speed at which it falls. I'm going to get my big paper clips out. I ran short. What's another way? So we're extending the wings to see if that affects the speed at which the rate at which it falls. We're adding more weight to the bottom, right, with a bigger paper clip. And we're folding the wings in a different pattern to see if that affects the rate at which it falls. Anything else that we can try? Or that you would like to try? Colin?
You can make the body like shorter.
Make the bottom of it what?
Shorter.
Alright, so shorten the bottom of it. Should we try the weight and the shortening at the same time? No, why not?
Because then you have two variables.
We have two variables in the same experiment, right? That's no bueno. Alright. I'm out of the big paper clips. But I can give you two of the little ones. Would that be okay?
Someone can get burnt from pictures.
Oh, okay. Well, you need to stand up and test it. Stand up and test. Put the big paper clip on. Stand up and test. I don't know. You try it. Try it with it on and try it with both.
Okay.
See what you see. What do you think? Is it falling faster or falling slower?
Slow. Faster.
Well, try it. Stand up and try it. How do you know?
But without the other
Do some more minutes.
it's slower.
Yeah, put the little you on one side and the little you on the other side. Try now.
Those ain't disgusting. When
See the two U's? One on one side, one on the other side. All right. Let's see. All right. Are you absolutely sure? Try it again.
let's make a helicopter race. We should make a helicopter race. Let's do a helicopter race.
Wait, hold on.
Slower because it wouldn't get on top of it.
Okay. Oh, it does. Look how quick it spins. Leave the action together.
This kind of reminds me of the bomb that hit Hiroshima.
Oh, okay. Down, right down. It does. All right, back to your seats for me, please. Back to your seats. Let's answer a few of our questions. Let's answer a few of our questions. What did you learn? Share, please. What did you notice? What did you learn? What did you observe? As we change some things on your... Right over there. Go right ahead. As we change some things on your helicopter's horn.
If you put it in the bigger paper, it falls faster than this.
So were we right that we can affect the speed of a falling object by adding more weight?
Math.
Did we change the mass?
Stormy changed the math.
Stormy changed the mass. Stormy, what did you think? Can we affect the speed of the rate at which something falls by changing the mass?
Yes, it did a little bit. It spin faster than the original.
Ooh, okay. What caused it to spin? I noticed a lot of them spin. What causes those helicopters to spin? Bree, what do you think causes those helicopters to spin around as they go? All right, so it's doing something. What's happening as it's spinning? What's making it do it? You said it's catching on something. Is it the paper that's spinning? Is the paper spinning? Is the paper spinning on its own? Huh? Is gravity making the paper spin? Oh, phone a friend. Is gravity making the paper spin?
It's catching on like the wind or air underneath its wings to make it spin.
Oh, gravity, you're right. Is gravity making it fall down? Because gravity is a force that pulls objects down. Is our big idea. Is that true? In everything we've done today, have we seen gravity pulling objects down? Alright, but there's something that's slowing it down thanks to these things right here on the sides making it spin. What do you think that something is, Levi?
I expanded the wings, and my first read it was slower.
It did. That's exactly what. So you and Stormy came to the same. Yeah, I probably have to stand up to see that. Ooh, that's interesting. So if we extend the mass of something to see its effects, do we have to change the distance? That could be an experiment in and of itself, couldn't it? Carson.
I took mine and I folded them in and what that did, it made little pockets. And because of the what happened was when it fell, the pockets got near the road and it made me spin a lot faster and made my phone a lot faster, even though I was like,
All right, so we've definitely tested a lot of things, have we not? We've tested mass, we've tested, I saw folks back here doing distance, releasing it from different spots, right? We've tested weights, different weights. Did all of these things affect the rate, the speed in which an object fell? Oh, we'll have to see. So does gravity affect everything equally? Or you said yes. Why? How do you know?
Because when you released the helicopters with the same variables, like at the same way, at the same height, it came down at the same speed.
Oh, very good. Do bigger objects fall faster? So far we've tested your helicopters, right? But what if I took a sheet of paper? This is smaller, right? Smaller than my helicopter. If I drop them, are they going to hit the ground at the same time? But this is bigger. Don't bigger objects fall faster? Carson, pay attention. So this is bigger. It should fall faster, right?
Yeah.
Watch. Let's test it and see. What stopped the bigger object from falling faster? The what? The weight? Yeah. Well, which one's heavier, do you think? This one? So you're saying weight is a bigger factor than mass? Because mass is how much space something takes up, right? So which one, what do you think, affects it more? Kyle?
So the wind or the air in the room is able to move around the ball of paper faster than it would the bigger object, which has more mass.
Let me understand. Are you saying that there are forces or things, elements, factors that affect how gravity acts on something?
Yes, ma'am.
What's one of those?
Air.
Air. How could we test? How could we test? What would be a way that we could test the factors that affect speed when combined with that air? What is a way we could test to see if weight or mass, in particular mass, is there a way we could test to see if the mass, the size of something, right, how much space it takes up, is it influenced by that air? Sir?
The helicopter falls slow because the pattern of how it's folded makes it fall slow.
Okay, so you're saying we could maybe adjust the mass. Do we still agree that something that's bigger is going to fall slower? Oh, we have to do that. We have to figure out if bigger does equal slower. I need you to open up your journal to the page that you created today. And I need you to think. I need you to brainstorm. I'm going to give you 5 minutes on the timer. I want you to think of an experiment that we can do. And it can be anything. An experiment that tests if bigger objects fall slower or faster. How could we test? What could we do to see if bigger or slower objects with a greater or lesser mass fall slower or quicker? Because we decided that gravity affects everything. And that things do fall at different speeds or different rates, right? But that's because of the... So how could we test to see? I want you to come up with an experiment. 5 minutes. You fall asleep on my in my class, baby, you will sit out a break for the rest of the school year. Make sure it's worth it to you. Sweetie, I explained. I'll explain to you again. Experiment. Is it going to be like a helicopter in your experiment, or do you want to use something else? Because a lot of people were telling me about, before class, they were talking about balls, they were talking about trampolines, they were talking about lots of different things. It doesn't necessarily have to be a helicopter. How are you going to test? And this is your experiment. How do you want to investigate the effect of mass on falling objects? Do you have any ideas? Okay. They seem to be falling at the same rate, though. Well, you know, it's really hard to tell without some numbers. How can we get some data from your experiment? What can we do to get some numbers to actually prove, right? Because we got to prove it. We got to make a claim, what we think. We got to prove it with some evidence, some data. So, what's a way in your experiment? Which I'm saying that's a pretty good experiment. What's a way that we could get some numbers to 100? Because how it looks might be different, right? Because that's not a real good way to know for sure. ideas. Well, I like yours, Reed. Ooh, you're changing the material. Are you changing the mass? Okay, so when we test you're making a bigger poster, but so you're changing two things though. You're changing the materials and you're changing the size. I'm not disagreeing with you. I just want to make sure we're testing one variable at a time, right? Sure, come up with another one. Lauren's come up with two. I think that's pretty clever. I love the idea of testing not only material. So far, everybody did it out of what? Paper. Huh? Do different materials affect the rate, the speed or rate at which something falls?
What would happen if you took a normal flat piece of paper, a piece of metal, and dropped it, versus a piece of metal and extended it and it slides?
I don't know. That sounds like something that would be fun to see.
And
Sometimes it's fun. All right, do me a favor. 2 minutes. I want you to pick somebody in the room to share your experiment with. Pick somebody in the room to share your experiment idea with. And even if they don't have something, that's fine. You can share your good idea with them. And if you don't have anything, because you haven't been able to think of anything, that's fine. Listen to other people's ideas, because that's what scientists do. They communicate ideas. All right, 2 minutes on the timer. Stand up. Walk around with your journal. And just let somebody read their idea to you. Walk you through it. Sometimes, oh, good. Write it down, baby. You only have 2 minutes to share with others.
I didn't think about it yet. All I said was yes. So I just take I am not.
What did they say?
I am Russian. I can do wait. No. Mine
All right, wander back to your seat for me, please. I'm going to hand you out a sticky note. I'm going to hand you out a sticky note. What I need you to do on the sticky note is write down the materials that you're going to need to do your experiment so Miss Hudson can pull it out of her storage and let you do your experiment. Now, there's a problem. You got to put something down in writing while I'm handing out the sticky notes. You've got to have to have a way to collect what in an experiment? Data. All right. So how do you know? You can't just look at something and say that looks faster, can you? Because that would make faster an opinion word, right? And we can't have those opinion words all the time in science. So you have to come up with a way that you can really know which one is falling faster. Who has an idea? Stormy.
You can video it in slow-mo.
You could video it in slow-mo. Is there another way that we could? Is there another way that we could test to see, to get some numbers to see which one really is falling faster or slower? Horn?
It's a little expensive, but you can get a radar gun.
Oh, we could radar. Very good.
We could do it over and over again and then just.
All right, but how are we getting measurements? How are we getting numbers to see which one really is falling faster? I know, just looking at mine sometimes, it's so close together. It's really hard for us to tell. So what would be a way that we could really test to see if your experiment idea is faster or slower?
There's like little things you can buy that are running, and then you put them in the
Okay, so it's like a timer?
no, it's a big button, and it lights up.
Okay, how is that going to give us,
You could like drop sugar it, and have to make
oh, okay, yeah. It's like a sensor that detects when something hits it and it'll light up. So kind of like a race. We cross to a finish line of a race. What else could we do?
Like you can have like 2 different bowls of water for them, whichever one, like you can see whenever they hit the water.
Okay, so but that way, usually if you're dealing with paper, that's a one-shot deal, right? Once paper gets wet, it affects the thing. This might be something to think about for those folks who are doing paper experiments. Yes, sir.
I mean, we could drop it and just time how many seconds it takes for it to fall to the floor.
Okay, so using timers, that seems pretty simple. Something that we could do to generate. So you drop them not together, but one at a
Time.
and then you could compare the numbers together. That might be a way. You need to come up on your sheet with a way that you're going to test and generate some data. And then I'm going to come around the sticky note so I can get your materials, okay? Make sure you write your name so I can get the right materials to the right person. On your sticky note. You got to come up with a way that we're going to get some measurement numbers, right? Because it's not just enough to look at something and say faster or slower. That's like pretty and beautiful. People have different opinions. Thank you. In your journal, you are writing me the way you plan to gather data from your experiment. And on the sticky note, you're writing your name and the materials that you're going to need to complete your experiment. So if you're testing balls, you're going to tell me what balls. If you're testing paper objects, you're going to need the paper and the kind of paper that you're testing, what you're going to need to do it.